Hey there. In today's lesson, we are going to talk about phylogeny or phylogenetic trees. So our objective for this lesson is to be able to compare organisms on a phylogenetic tree in terms of relatedness and the time they appear in geologic history. And by the end of this lesson, you should be able to interpret a phylogenetic tree to determine the relatedness of different organisms. We'll come back to the dichotomous key part later in this lesson, okay? So for now, right, we have already talked about the classification system as a whole and the history of classification, but now we're going to dive a little bit into the field of taxonomy, which is specifically a field of biology that relates to classifying said organisms. So taxonomy or taxonomists, right, their job is to try to organize organisms, right, based on their similar characteristics. Okay, we reviewed those characteristics when we talked about the 3 different domains and the 6 different kingdoms, right, for all living things. Well, those kingdoms can be further subdivided, right, into a phylum, class, order, family, genus, and species. Okay? And again, this is an ongoing process, right, that can change over time, right, as new evidence is found or discovered. So for instance, phylogeny, right, can now be included to help us classify organisms. So, and then remember Carl Linnaeus, right? He gave us that binomial nomenclature, the 2-name naming system, so genus and species. So if 2 organisms share a genus, we know they are closely related. Okay, so Ursus arctos and Ursus maritimus, they are both within the same genus. They're not the same species, but they're like cousins. Okay. All right, so briefly, phylogeny again is just the evolutionary history of a species. So going all the way back to the very first life forms, which we know were anaerobic prokaryotes, right, all the way to then your first eukaryotes that we right, talked about evolved through the process of endosymbiosis. We talked about the endosymbiotic theory, right? So we're pretty confident that all of these organisms share a common ancestor. So we can then kind of put the pieces together and build an evolutionary history, right, to show the relatedness of organisms based on their shared inherited characteristics. So how closely or distantly related 2 organisms, or 2 species are to one another. So a phylogenetic tree is just simply a diagram that shows the evolutionary relationships between species. So again, are they closely related? Are they not closely related? Right? Do they share a common ancestor? Okay. So a single phylogenetic tree can represent the evolution of a group of organisms. Now that we're not talking about every single organism on Earth, just like a specific set of organisms, okay? If the organisms are closely related to each other, then they will be placed closely together on the diagram, right? And then organisms that evolve from a common ancestor are connected, right, with these branches. So all of these organisms branch from a common ancestor right down here at the bottom of this phylogenetic tree. Okay, so this tree tells us that all 1, 2, 3, 4, 5 of these species do share a common ancestor. So from a phylogenetic tree, we can learn which groups of organisms are most closely related, groups of organisms that are least closely related, as well as which groups of organisms diverged first or are the oldest, or the most like not related to everyone else. Okay. So how do we read a phylogenetic tree? All right, well, we always start right at the root. Okay, this is your common ancestor that everyone else in the tree came from. Okay, so as you move away from the root, right, you start to move forward in time. Okay, so past, I don't know if I'll be able to write this right, past, right, and then present. This is really hard. Okay, I'm just put PR for present. Okay, so when you have a speciation event, that's where you see a branch in the family. Oh my gosh, guys, it's written right here, past to recent. The key was included. Okay, here we go. So every time you see a branch point, okay, that is where you have a speciation event. Okay, um, phylogenetic trees can show the extinction of organisms, like what we see here, right, for species B, because it kind of has this little line. Okay, sometimes you also see where the line just doesn't even make it all the way to the top. And then each node, right, here's a node, here's a node, right, those represent a more common recent ancestor. So let me get rid of all of my drawings. Okay, so right, this blue node, right, is the common ancestor to everyone, right? But this slightly, purple node is only a common ancestor for species C, D, E, and F, because species A and B, right, they branched off before that, okay? So phylogenetic trees can show us how closely or not closely related two organisms are to each other. Now, what phylogenetics tree do not show us? Okay, they do not say, okay, species A evolved into species B, and then species B evolved into species C. No, okay, we're not showing the path of evolution. We're showing how closely related they are. Okay, like it's like a family tree. Okay, you are not, your cousin did not come from, right, your grandparents, right, you're related. Okay, they also do not show one species is more evolved or or better than another. Okay, they are not ladders. Okay, they are simply a family tree of how closely or distantly related groups of organisms are to each other. Okay, all right, so I'm going to give you this just as a kind of an example, and I'm just going to have you tell me what could we predict from this phylogenetic tree. So there are quite a few examples here. We could say something like, what are these, whatever this word is, prosimians, right? They evolved way back here, right? So they were the first to branch off. So they are, the oldest. What else we can predict? Chimpanzees and humans are the most closely related within this group of organisms. Okay, so there's a lot of information going on here in this phylogenetic tree. Right, and that's kind of the idea. Again, we're just showing evolutionary relationships, right, among a group of species. Okay, so that's it for these notes. If you have any questions or concerns, just let me know.